Good morning. How's everyone doing? Can you hear me okay? Awesome, cool. Well, thanks for coming to our breakout. My name is Jonathan Morin, and I have my colleague here, Madhu, with me. Let him introduce himself later. We're going to be talking a bit about networking and security, but from a bit of a different lens than, at least in the networking space, we're used to talking about networking. So we're from VMware, and as VMware kind of comes with our customers across their cloud journey, even if you think back to VMware's original days of hypervisors and VMs, it was really about building a platform that the business could run on, that devs could build apps on. So as those platforms are changing, whether from like the container orchestration level like Kubernetes, or today we'll get a little bit more into the networking and security platform level for those microservices. VMware is just on that continued ride of building those platforms for developers, for the business to run. We'll talk a little bit about that. So I said networking. So I'm going to ask what you think of when you think of networking. So raise your hand if when I say networking, you think of some routers and switches that maybe look like this, and we're going to build some topologies, and we're going to log in with a CLI and configure BGP and OSPF, things like that. Anybody familiar with any of that stuff? A few hands, okay, a lot. For other folks we talk to, when we say networking, they think of this. I just created a cluster, in this case in AWS Fargate. I'm not even going to worry about Kubernetes orchestration. I just have my container on my laptop. I'm going to throw it up into the cloud. Shoot, but I still have to give it an IP address and worry about what VPC it's in, what subnet it's in, and what other microservices this service is going to talk to, and what are the networking implications of that. So for whom did that come to mind when I say networking? Okay, another mix of hands. I think for what I'm seeing then is for all of us, we realize that networking kind of affects everyone in these different ways. So why is it so hard? And why do we look at that AWS page and say, why do I have to configure the IP address? Why can't it just work? I want to get on to building my app. I want this to be automated. Why can't these be part of my CI/CD pipeline, which Madhu is going to show us a little bit more of later? Why is that so hard? Well, if we wanted to make it super easy, super fast, which is important in this day and age, that's part of the reason microservices exist in the first place. Or however we're building our apps, we want to bring new capabilities to market. We want to move fast. So for the network, that might mean just configure a big blast radius where everybody can talk to everybody, no problem, broadcast everywhere. Does that sound good to anybody? No? See, even though it's sounds really fast and it would make things really, really easy, it still just gives you that, but I don't think that's the right best practice, and I'm not sure why. And you could I would frame that why around security. We still want to segment who should be able to talk to what. As more and more apps move to the cloud over the past 5 to 10 years, we saw that pretty infamous spike in folks who shouldn't be getting access to data and making headlines in many cases, and many cases that we don't hear about, that luckily don't make news. But across the board, we see all of our customers, enterprises from the data center to the cloud, rethinking their security strategy while still wanting to move really fast. So that's how we look at networking. How can we make from layer 2 to layer 3 up into layer 7 what the application needs super fast and automated, while still being secure from the business context, from the context of what your application needs, what other components of that application need to talk to what other components of the application. And so we're going to get into some of the architectures of things that VMware is working on, but also in the context of things in the industry. Before I get to that, I just want to go back to that point of who we're really thinking of when we talk about some of this stuff. Again, networking does affect everyone, from the apps we use on our mobile phone to even when we do talk about app development. Of course, there's the network team who traditionally focuses on that stuff we showed in the beginning, building that network infrastructure so that we can get that raw connectivity. But more and more, there's these platform teams who are also serving the developers, who are owning that Kubernetes orchestration in many cases, owning, maybe in some cases they're called the DevOps team or SRE team, or maybe some of the roles we see in those teams, or the folks who end up owning the pipeline, whatever their titles are. We also see a lot of folks calling these teams cloud teams, cloud architects, basically the folks who just care about that platform that should run all the time and serve the development team. And that's really the team that more and more we see partnering with our network teams when it comes to doing a lot of the stuff that we're talking about, so that networking can get out of the way of app development while still doing it in a secure fashion, while still allowing the network team to maintain, focus on what they care about. So what does network team care about? I just want to maintain uptime. Any application change, I'm going to look at the ticket for a few days, maybe a week, maybe a couple weeks. I want to talk to my firewall team. I want to make extra sure whatever change you just asked me for, whatever new VLAN I have to go configure for your app, it's not going to touch the network, because that's how I'm measured, which can be a hindrance to speed. What does the pipeline team care about? Well, they want to keep the pipeline going. So allow the developers to do what they need to do, while also maintaining uptime, right? SREs in particular are there to make sure Site 1 goes down, or Cloud VPC 1 goes down, VPC 2 is ready to go for that application. And of course, devs don't care about any of this stuff. They just, as far as I'm concerned, I just want to build features, ship code, and hopefully the networking is out of the way. And of course, the security team is in, peeking over the shoulder of all these folks and making sure we're doing all this in a compliant way. So both Madhu and I work at VMware in the networking and security group, and we very much see our roles kind of, I showed that scale slide, balancing speed and security in a way that creates the glue that allows all of these teams to do what they need to do. And my slides somehow stopped. OK, so if we go back to that scale, what would a network model, network platform, or even just like a best practice of operations look like that allows us to integrate both? So the connectivity would be automated. We need stuff to talk to each other. That's the whole point of networking. But the security policy of who can't talk to who. So app endpoint A gets to talk to app endpoint B, but not C. That's also automated. We're not waiting for these things to get processed. No tickets. It's, again, just automated. Increasingly, we're seeing customers run their apps, of course, not in AWS. That's been happening for years. But also, in some cases, they've gotten some free tokens and tickets for Azure, and have some apps, or maybe even some app components in Azure. Or maybe they like some new machine learning algorithm in Google Cloud that they prefer to AWS. So we're actually already seeing today a good amount of multi-cloud operations, and certainly hybrid cloud operations. So from the networking and security standpoint, this should be able to just be consistent everywhere. And the networking is reacting, at the end of the day, to the app, not the other way around. The app isn't waiting for a network ticket to be processed. The app needs to do what it has to do. And how can the network learn what the app needs and not what it doesn't, so it continues to do so in a secure fashion? So who's familiar, actually even before I go to this, who's familiar with the OSI model? It's a networking nerd's favorite. So I think all of us, devs, DevOps teams, networkers, we all like abstractions. And probably every single talk we're going to go to today is going to be all sorts of levels of abstraction. OSI is the network champion's favorite abstraction model. We're starting to, this is something we started using recently just to simplify that a little bit, and also kind of update it towards how we see teams organizing around, again, app development and getting code to market in a way that the networking and the infrastructure and the security policies and all the operations that the network needs to keep running is automated and secure, and in a way that each team can understand and cares about. So for starters, the physical infrastructure, that should just work, right? Especially in a world of cloud. I mean, who's configuring the Cisco CLI in the AWS cloud? I mean, nobody, at least in terms of your app team is concerned. But the virtual network infrastructure already starts to get interesting because even in the cloud environment, that's where, OK, what IP address am I configuring? That's at layer 2, layer 3. What makes sense? Which VPC should this app component be in? I need to start to think about that now. And that's where we're really going to dive in for starters. Madhu's going to show us how we've leveraged interfaces built by the open source community, so the CNI. And maybe just for a show of hands, is anybody familiar with the CNI, the Container Network Interface? Anything like that? Cool. Well, great. That means we can take some time to talk about it a little bit. We're not the only ones who've used this interface. The nice thing is the industry has aligned around, for microservices, for containers, what is a standard interface to talk to so that we can have this end-to-end network platform and some interoperability across those. After that, I'm going to continue walking up the stack later in the talk and talk a little bit about service mesh. Where do those fit in? Why do we have this new layer in between what the application is doing and what the infrastructure is doing? And then, of course, all of this is servicing what's on top, which is just the cloud-native applications themselves. So this is kind of a bit of an infrastructure view from an app standpoint. So CNI is not that new, the Container Network Interface. It is a cloud-native Foundation adopted project, I think announced as of last KubeCon in December. But of course, that's just the interface. So what does the networking need to do? If we're talking about automated layer 2 connectivity, layer 3 connectivity, security policies, who should be able to talk to who, that still needs like an end-to-end network platform. Luckily, Open vSwitch is also a component to automate a lot of that side, layer 2, layer 3 side. But what we've been working on is putting that into like an end-to-end platform. So you can download it and run OVS today. But then the question comes about like, OK, what about the firewall security policies? What about as I scale my application, how the automated load balancing services apply to that? So we're trying to get the network out of the way and consolidate all these functions into a single platform, something VMware has been working on called NSX. So for this layer deep dive, just to show you how we're seeing customers operationalize this layer in a world of cloud-native apps, Madhu's going to take a peek, give you a peek into how NSX works at that layer. And then we'll flip back and get to the service mesh layer. So Madhu, why don't we switch here? Make this more interactive and make sure that we're getting to some of the stuff that's more interesting to you guys.
Can folks at the back hear me? No? OK. Yes, thank you. Oh, yes, thank you. Thanks, Jonathan. So what I want to do was kind of walk through what customers do, what we've seen happening in the industry, but also go a little bit deeper in terms of how the platform actually works, and kind of tie it to the best practices that Jonathan was talking about. So I just have like a slide or two about Kubernetes. Most of you, or show of hands, how many of you are kind of familiar with the whole general Kubernetes, what it means? Excellent. So we all know we have a Kubernetes, one or multiple masters, couple of nodes, containers in them. Now I wanted to kind of just spend a second on this because in the Kubernetes world, from a networking perspective, you have an IP address that's shared with all the containers in the pod. But how does that translate to a guy who's providing networking for all the apps, for all the containers? That's what I want to talk about next. Now, you can implement that in different ways. As Jonathan mentioned, the VMware NSX platform implements it in a specific way. What we do is we kind of separate out the routing and the switching, obviously L3 and L2. We assume you will already have what we call as a layer 0 router dealing with your BGP, EVPN, north-south connectivity. Every time a developer wants to create namespace and start writing their apps, what we do internally is create another NAT boundary. We put another L3 segment there, a tier 1 router. We configure NAT so that the apps can talk north-south. And then we also create a L2 segment so that your containers can also talk between them. That makes it easier for applying security endpoints at a specific container interface level. That's the CNI. So what happens at the backend in NSX is, once from an app developer perspective, we don't want to complicate the process a lot. The app developer still creates a standard namespace. At the backend, because of the whole CNI and NCP, and NCP is Network Container Plugin. That's the plugin that we have that interfaces with Kubernetes, OpenShift, Docker containers, anything that you want. It handles all of the networking, the segment creation, the L3 routing. It handles all of that at the backend. So you create a namespace. That's when the boundary is defined. And then once you run your container inside it, NSX comes in, make sure the connectivity between your containers and your routing is set up. It'll set up a firewall boundary so that you can specify security policies right from day zero. Day zero from an app perspective. The moment the app comes up, we want it to be secure. Irrespective of whether you scale up, scale down, you have multiple namespaces, the workflow is still the same. Now, from the NCP CNI integration perspective, what NSX does is, every time there is a new container comes up, because the plugin understands that there is a new container coming up, there is a request that is sent to the NSX policy manager. That does all the heavy lifting at the backend. And it also knows the IP address that the container is requesting. And in Kubernetes, you have the ability to have, obviously, namespaces and app names and all of that. What we do in NSX is translate that to tags within the product. Now, obviously, I'm just having a couple of lines there about the app name, the namespace name. So the app developer, all they have to do is make sure they kind of are in the right namespace. Internally, what's going to happen, what's going to change is you're going to get tagged. These apps, these CNIs, these endpoints are going to get tagged within the product. Now, why do we want to do that? Because we want to create dynamic security policies and security groups. Once you have tags, it gets really easy for the product to create firewall policies, saying that, hey, app endpoint A can talk to app endpoint B, but B cannot talk to C. And when I say dynamic, it's because I can create these rules and these policies. They are enforced even before the app actually comes up. As long as the apps are tagged properly, it translates to a tag within the product, which is picked up by the security layer. I want to kind of, that was how the platform kind of works. I didn't want to spend too much details into that. If you folks are interested, we are in the booth outside. Come find us. We are here today and tomorrow as well. We can talk more on that. But what I want to go next is kind of walk through what app developer does, what would be his view, kind of actually take you through deploying an app on the product itself. For this, I wanted to kind of use, there is an open source app called PlaneSpotter. It's really cool. You can install it. You can install it as a VMs. You can install it as containers. You can do a mixed and matched approach just to get familiar with the whole platform. That's fine. It's fairly, I wouldn't say complex, but it has components that kind of gets you going with the whole container world. In this, OK. Where is it? OK, it's on GitHub. You're always free to go download that. What I've done is I've deployed this app, or I'm going to deploy this app in my setup. I have recorded some of it, if I can get this going. Yeah. So this is the dashboard of the platform, the NSX platform itself. I just wanted to kind of start from here because obviously it gives you a dashboard. It tells you all of my control plane, my data plane, my management plane, everything is up and running. I do have some amount of virtual servers, load balancers, segments, and routers created. Now I want to talk about load balancer because in any app, you want to scale up. When you're scaling up, most likely you're scaling up at the front-end level, which means you need to load balance between those different front ends. As an app developer from a Kubernetes world, all you're familiar with is doing just scale out or providing a limit, saying that, hey, I want four front-end nodes or 6 front-end nodes. You really don't want to worry about what's happening underneath at a networking layer. Similarly, I think I'll talk about it a little bit more. The load balancing algorithms, how to configure the load balancer, do you want round robin, all of those things, again, as app developer, you really don't care about it. So initially, I'm showing that within the product itself, there is no apps deployed. So your load balancing policies, it's nothing. There is absolutely nothing configured. And from a security perspective, I have already created basic firewall rules, which just says that, hey, this whole app is there. It's right now from a non-best practice way of saying that allow everything from A to B and B to C. Because I want to show going forward how just segmenting at this point makes life a lot easier. Again, as an app, so all of this is kind of configured right on day 0. The developer comes in. He wants to now deploy a new app. I'm just showing that there are some switches, logical ports are remaining. Set the namespace. Because of my app, I have MySQL, Redis. There is a front end. There is also Nginx at the back. I'm just deploying all of them. This step should be quite familiar. It's a very standard way of doing it. Again, the point here is the developer is not worried about what's happening from a networking perspective, not worried about what's happening from a security perspective. He's just coming in happy, comes in on a Monday morning, maybe had a nice weekend, it just starts deploying this. So that's good. What happens at the back end? The plugin kicks in. It knows that, thank you. All of this requires some load balancers, some switches, some container ports that are created. Now, because by default, my config of my app said I just need 2 front-end services up and running. That's what it's already configured in the load balancer. Again, the developer didn't do any of this. The plugin is smart enough to understand that this is a front-end plugin. It requires load balancers, and it comes in and configures that within the product. I just picked a round robin method. The other advantage of having tags is you will be able to look at every single entity, every single object that's created in the platform because of the app that was deployed. For easy naming, I just gave my tag as planespotter. Searching on that in the platform will give you the entire logical routers, switches, NAT rules, load balancers. Every single component that gets deployed in the platform will have that tag. Now that the app is deployed, I want to make sure the app is actually working. So I'll just get the URL, open that in a browser. And that's my app. It's pretty interesting. You can actually go look at flight details of obviously registered airplanes, live data. Unfortunately, in my case, my lab that I used to set this up is in kind of my office DMZ. I couldn't connect to the public. One of the APIs that I need to get live data, that wasn't working. So just sorry about that. But what I want to show here is every time I'm doing a refresh It's load balancing. I can just see the IPs change. I know that it's actually getting serviced from different front-end containers. All of this is great. Now I want to scale out. Again, as app developer, I just come back, or I do what I normally do. I will change I think I give a limit of 4. I say, hey, my replica should be 4, so it'll make sure the Kubernetes platform itself will make sure it's always 4 at any given point of time. Now, what did this do again in the backend? Obviously, there has to be a change in the load balancer, because now you've got to load balance across all 4 nodes. Go back to the load balancing configuration, and once we look at the members, 4 of them are already there. It has already recognized that there are 4 front-end endpoints with 4 IP addresses. Now, all of this is great from a normal working perspective. The app developer is happy. He's not worried about network. But what about the security guy? Now, what I want to show here is in this app, there is, I'm just making sure that it is servicing from all the different front-end nodes. There is a specific, I just put in a very simple MySQL rule saying that, hey, I want to be able to control MySQL connectivity. That was the screen at the back. And if I go back to my app health, again, the red ones, because I didn't have connectivity from my lab, but what I'm more interested in the second one from the top, which is database connectivity. The app has a kind of a very simple metric showing that whether all my services are up and running, is the connectivity fine. Everything is happy. As a developer, I'm good. I'm continuing to work on it. Now, for whatever reason, the security guy comes back and says, hey, I don't want to allow MySQL. Now, in this case, somebody is doing this explicitly, but in a working environment, what if network connectivity actually goes down? What happens? Your app obviously doesn't work. You will see that the network connectivity is down. At this point, the developer panics. He's like, OK, do I need to call the security guy? Do I need to call the networking guy? Ideally, the platform itself should be able to tell you what's wrong with it, and it should kind of give you a hint about who you should go talk to. So what I wanted to show there was within the NSX platform, we have something called a trace flow. It has the ability to send specific tailored packets against or between any two customizable workloads. So here I'm saying that because I know MySQL connectivity is down, I'm saying that from my source app to my MySQL server, let's see what's happening. Why is the packet getting dropped, or why is the connectivity not happening? So I'm just forming that trace flow packet here. And I'll just do obviously I need to go change my destination port, MySQL standard port 3306, and I'm interested in a TCP packet. Do a trace. Now, the platform, because all of the troubleshooting is built into the platform, and the platform knows about all the internal stacks. It knows about the container interface. It knows about the container host. It knows a little bit about the virtual networking, and it also knows about security. It knows what firewall rules are enforced and where. Now here, the trace flow came back and said that, hey, this specific packet is getting dropped. Not only that, it's getting dropped by a firewall rule, and it's getting dropped by a very specific firewall rule with the firewall rule ID. So as the admin, I just go look at and see what my firewall rule ID is, or what that firewall actually means. OK, fine, I know why exactly my app isn't working. Again, obviously, this was done for the demo, so I'll flip it back. And before I go and check the app, or I think I do check the app first. OK, that's good. So obviously, the connectivity is back up. Everyone's happy. But I want to kind of go back quickly and look at the trace flow again when things are actually working, because that'll give a glimpse in terms of the different hops a specific MySQL packet is taking within your application deployment. So I just go back there, do a retrace, and you can see that the firewall is being enforced both at ingress and egress at both endpoints. So this kind of gives you a clue in terms of what kind of specific microservices rules that you can specify within your application. You can say that, hey, you can talk about direction, you can talk about ingress, egress, you can talk about source and destination, along with the regular 5 tuple that usually firewall rules are used for. Okay. So networking, I know we had pipes, so I thought I'll just have this slide in there. All of this was great. Now, I talked about setting up NSX, setting up your apps, getting everything to work, but from a CI/CD, continuous integration and development and delivery perspective, how does that all add up? Obvious solution is automation, but I want to talk about one specific tool that at least I use. It's, again, another open source one. It's called Concourse Pipeline. It's built on Ansible. Folks familiar with Ansible? Or how many of you happy with Ansible? Okay, great. One of the feedbacks that I generally hear about Ansible, although personally I don't agree with that, is there is an initial starting curve to get familiar with Ansible, and it's hard, and I don't want to do scripting. Those are the kind of the 3 things that I hear about Ansible. Well, again, I don't necessarily agree with all of that. But with Ansible, yes, you can automate deploying your platform, deploying your apps. All of that is great, but wouldn't it be really awesome if you have one single CI/CD platform that everyone that Jonathan talked about, like the platform guy, the security guy, the app developer guy, can use to continuously work on a day-to-day basis? So Concourse Pipeline is one of that. Again, that's the site. I will quickly show, in fact, you know what? Let me do a live demo on this. So folks okay with a live demo? And okay, that's the Concourse Pipeline. What is a pipeline? Well, you can look at it as a continuously running makefile. What I've done is I have written multiple pipelines, one to install the product. Yeah, this is probably better. One to install the product, the other one to set up all the day zero config, like north-south connectivity, and the third one to configure app-specific details, like, oh, do you want more load balancers? Do you want specific security based on the app? Those kind of things. And from a CI/CD perspective, it's very straightforward. Go here, click on the plus, it will start. Again, for folks familiar with Ansible, this screen should kind of look familiar to you. It uses Ansible at the backend. Now, the advantage of doing it this way is, as automation guys write tools, everything is generally in GitHub. Now, the CI/CD platform will actually do a git pull of your pipeline, of the platform itself, of all the required binaries of the automation tool itself. It'll then tie everything together and then run it for you. Obviously, I'm showing it in a UI mode here. You can also do the same thing with APIs. Go look at what's happening. You can go back and forth between different runs. Or if I had an error, you can actually go look at what the error was, come back, fix it. And in terms of having the same platform servicing different end users, the install guy or the day zero admin is worried about the install part. The app developer is maybe worried about another aspect of your pipeline, so you can just run only that specific segment. Same tool, you just come in and then run that segment. I could run, but let's see. go through fairly quickly because all the components are already deployed, but nothing magic is happening here. Just it's doing a git pull of all the Ansible modules that I need, running them, giving the output in a fancy UI. So that's it. Yes.
Has this been updated for 2.4 yet?
This specific pipeline that I'm using, no, not yet. The one on GitHub, it's already for 2.4. The one that I have is for 2.3. The question was for 2.4 in a sense that the NSX version 2.4. Yeah, thank you. So back to you, Jonathan.